And then now let's discuss about finding the equations of a straight line whereby you will be given a certain point. The first thing to understand or equation a straight line is in the form of y is equals to mx plus c. So give the standard form here equation a straight line. For example, only y is equals to 2x plus 3. So it's important to understand that this m re gradient ke this line, and then re gradient re ka find between 2 points re shumisha the formula ya m is equals to y2 minus y1 divided by x2 minus x1. Another way of finding the equation ko shumisha this one, y minus y1 is equals to m at x minus x1. So utloba only a certain point whereby, for example, only a point which is 2 and 3. Let's say only the gradient which is 2. So ga o nyaka gore o tla find the point ya c, re tlo substitute ka point ya 2 and 3. So e rela gore mo re bonago y1 re tlo substitute ka this point ya y, and then mo re bonago x1 re substitute ka this point ya 2, and then ra kry-a the equation. So it will be in the standard form yaba in this way. And then another thing that is very important is to know that generally the lines that are parallel, let's say this line is parallel to this line, this is line AB and this is C and D. AB is parallel to CD, it means these two lines are equal gradients. Let's say gradient ya AB is 2, so it will automatically utsebale gradient ya CD, which must also be 2. So it will gradient ya AB and then a parallel to CD, whereby as gradient ya CD, when you must know what gradient ya CD is 2. So these are the important things you should know them. And then another thing that is very important, lines that are perpendicular. Let's say something like this one. Let's say this is line A, this is line B, C, and D. So with this, line ya AB is perpendicular to line ya CD because the former 90 degrees. So with this information, we can find a gradient ya AB, gradient ya CD, and then also we can find a gradient ya CD, gradient ya AB. What you should know, if lines are perpendicular, are the products of their gradients -1. So gradient ya AB times gradient ya CD -1. So gradient ya AB, let's say gradient ya AB or half, half times gradient ya MCD, and then is equals to -1. So from there I find a gradient ya CD very easy because I divide both sides ka half. So I divide both sides ka half, gradient ya CD -2. So this is the easiest way you're going to find one of the gradients of A1 whereby the lines are perpendicular. This question area determines the equation of a straight line which passes through the points A and B. So file 2 points just straight line. The first thing to find the gradient. So let's find the gradient here at these points. Let's say this is x1 and then this is y1, and then let's say this is x2 and then this is y2. So from there to find the gradient. So gradient here AB it y2 minus y1 divided by x2 minus x1. So y2 minus y1 get 20 minus 6, and then x2 is 10 minus x1, which is 2. So 20 minus 6 is simply 14, and then 10 minus 2 it's 8. So 14 divided by 8 over, which is 7 over 4. So now we're gonna lay the gradient. So from this gradient, our equation here in the form of y is equals to mx plus c. So originally y is equals to, and then this is my m can substitute, which is 7 over 4. And then from here ke tlo tshwanela gore ke find the point ya c. Ge o nyaka gore find the point ya c, o choose any point e ba file yona between a and b. So it's all up to you to choose a thing. Let's say ke choose a point ya a, which is 2 and 6. Remember the coordinates in terms of x and y. So this is x and this is y. Erela mo ke bona go x go substitute ka 2, and then mo bona y go substitute ka 6. So re la re go ba le 6 is equals to 7 over 4, and then mo go substitute ka 2. So now ka kgona bona gore ke na le the unknown c, nka kgona go e solve. So ke na le 6 is equals to, and then 7 over 4 times 2 is the same as 7 over 2. And then now can you find a value of c. So I can say c equals to get transpose 7 over 2. So can I 6 minus 7 over 2, and then 6 minus 7 over 2 is the same as 5 over 2. So ke kry point ya ka ya c. So now because ke kry point ya ka ya c, e rela gore ke tlo tshwanela gore ke ngwale this equation in the standard form. So in the standard form it's like y is equals to a gradient which was 7 over 4, and then point yaka c grade, which is 5 over 2. So it's all up to you right now ushumisha which point you find a c. Ukashumisha a, ukashumisha b, but at the end it will create the same answer. So this is the equation in the standard form. Let's try y minus y1 is equals to m at x minus x1. To create the same answer. Remember we gradient already, which is 7 over 4. So from there, we can substitute a point here. Let's say we choose a point here a again, which is 2 and 6. So can y minus, and then y1 yaga, because this is y and this is x, we substitute 6, and then s for gradient already, which is 7 over 4, and then this is x minus, and then x1 ka substitute 2. So this is 0.2, and then from there can solve this equation or in the standard form. So the first thing, it will just 7 over 4, can multiply everything that is in the bracket. So from there, y minus 6 is equals to, and then 7 over 4 x, because 7 over 4 times x is just 7 over 4x, negative 7 over 2. But now ke nyaka ngwala equation yaka gore ebe in the form of y is equals to, so re la gore ke tlo tshwana gore ke je this minus 6 ke she to the other side, therefore ke tlo ba le y is equals to 7 over 4x, and then minus 7 over 2, and then ka plus ka 6, because ke like terms, therefore la y is equals to 7 over 4x, and then re ka try to add these two numbers ke like terms, and then it will 5 over 2. So ka kgona bona gore they are the same. So it's all up to you when I shumisha which method. And then what about this question? This question here determine the equation of a straight line which is parallel to the line y equals to 3x minus 2. Rinyaka a certain equation mo that equation is parallel to this line here, y is equals to 3x minus 2. What you should know gore rinyaka the equation here, a certain line parallel to this one. This is not the equation here rinyaka. So right now what we know gore, if this line is parallel to another line e rela gore di na le equal gradients, and then on this equation re tseba gore this is the gradient. So e rela gore le another line e re nyakago yo ba le gradient ya 3 because they are parallel. So e rela gore with this information ke na le y is equals to mx plus c, and then ke a tseba gore my gradient ke 3 because ba re boditše gore they are parallel. So e rela gore from here ke tlo tshwanela gore ke find point ya c. Finding point c, it's very easy because ba re file gore that line e feta through this point ya p, which is 5 and 3. So re la gore ke tlo substitute ka point ya x and y mo ke bonago x and y gore ke kgone go finda point ya c. So point ya x ke 5 and then point ya y ke 3. So this means 3 is equals to, and then this is our gradient, and then now ke nyaka go substitute ka point ya x, which is 5. So this is 0.5, and then from there nka kgona go solve point ya c. So e rela gore ke na le 3 is equals to 3 times 5 ke 15, and then plus c. So re la gore finding point c is equals to 15 minus 3, and then 15 minus 3 is 12. So e rela gore from there ke kry-ile the equation, which is y is equals to 3x plus 12. So now ke ngwadile in the standard form. Remember ge o rata o ka šomiša this equation ya y minus y1 is equals to m at x minus x1. So it's all up to you to šomiša which one. And then let's do part b, which is similarly part a. So what file the equation ya gore ke y is equals to 2x plus 1, and then this question ya gore find the equation ye lore parallel to this line ya y is equals to 2x plus 1. So re tlo dira the same thing. Ra tseba gore if they are parallel e rela gore they have equal gradients, so I can say y is equals to 2x plus c, and then ba re file gore e feta through point ya 2 and 3. So from there ke equate. So point ya y is 3, and then point ya x, which is simply 2, and then from there nka kgona solve point ya c. 2 times 2 is 4, and then plus c. So re la solving c is the same as go tšea this point ya 4 ka iša to the other side. So re la c is equals to 3 minus 4, and then re la point ya c it's negative 1, and therefore the equation ke y is equals to 2x minus 1. So ke kry-ile in this way. And then what about part c? Part c ba re file gore this one is perpendicular to the line ya re nyaka go find the equation ya gona. So re tseba gore if they are perpendicular e rela gore the products of their gradients e lekana le negative 1. So remember gore re tseba gore this m1 times m2 they must be equals to negative 1, and then re nyaka go find this gradient because re nyaka go find equation, but ba re file gore this one it's negative 3 is perpendicular to this one. E rela gore if this is negative 3 and then times m2 is equals to negative 1. So from there ge ke nyaka go find m2 re rela gore nka divide both sides ka negative 3. So this one and this one cancel, so re rela gore m2 e lekana le 1 over 3. So from there e rela gore I can say y is equals to mx plus c. So my gradient ke 1 over 3 x plus c. So ke nyaka go find point c. So because ke na le this point which is 3 and 1, e rela gore finding point c is very easy. So this is x and then this is y. So e rela gore this is 1 and then 1 over 3, and then this is 3 and then plus c. So ke na le 1 is equals to 1 over 3 times 3 e tlo fa 1 and then plus c. So re la gore point ya go ya c ke 0. So your equation it will be in this form: y is equals to 1 over 3x, because this is just 0, so there is no need to argue. So if gradient ya is 0, in order gore line ya e feta through the origin, so ya kgonega. Don't think gore it's not possible, so it is possible. And then what about part D? But this one is perpendicular to this one, and then barfile the y-intercept. Right, so they are perpendicular, the products of the gradients electrically -1. So that's about m1 times m2 electrically -1. So this gradient barfile ke half, and then we can find this gradient. So from there I can divide both sides ka half. So re la gore my m electrically -2. So from there I can easily find the equation. So re la gore ke tseba y is equals to mx plus c. So y is equals to, so gradient it's -2. But this question as far a point varfile the y-intercept. This point your y-intercept give this point ya c. So re la gore I can easily substitute ka yona, and then this is c. So this is our equation. And then what about this one? Determine the equation of a straight line which is parallel to the x-axis, passes through point 5 and -6. The moment we go by the equation that is parallel to the x-axis and the y-axis, the first thing is to imagine the Cartesian plane. This is y-axis and then this is x-axis. Varfile point ya 5 and -6. Ratsabore this point ke x, and then ratsabore this one ke y. So I can say this is 0.5 ikaba somewhere here, and then point ya -6, let's say it's somewhere here. And then now, because this question area parallel to the x-axis passes through point 5 and -6, it's parallel to the x-axis, gets something like this one, because this is the x-axis, parallel, it's going to be something like this one. But because this question is very specific, it passes through point 5 and -6, if it through this one. So that equation which is parallel to the x-axis, I will simply say y is equals to -6. The reason get y is because it cut on my y-axis. So based on this question, what passes through 0.5 and -6. So for this question, get y is equals to -6, because if it through this -6, and then a parallel to the x-axis. And then what about part B? Part B is parallel to the y-axis and passes through 0.5 and -6. So it's the same point. Because it's parallel to the y-axis, it's parallel to the y-axis, expect it's only something like this one, because this is y-axis. These lines can only be parallel to the vertical line. So because if it through point 5 and -6, it will be this one. So this answer ya part B, x is equals to 5. The reason get 5 is because it cut through this point 5 on the x-axis. So in that way.